Welcome back. As requested, I'm doing chapter 3 and chapter 4, which is exploring, for chapter 3, we're exploring Linux file systems. Now, we already went through a little bit advanced yesterday in our class, but today I'm doing a replacement for the Hurricane when they cancel our class. So we have exploring Linux file system and Linux file system management. So we are going through both chapters. We already went through chapter 5 and 7. So we are going through 3 and 4. We already completed the introduction and the installation. Okay. I'm going to use the slides as usual, and in another video I may open the lab and work through the lab. So this is exploring Linux file systems, and this is the objectives of the outcomes of the chapter. Now here is the Linux directory structure. So what's a directory? The directory used to organize files into a logical tree structure stored in a file system of a specific partition in the hard disk of or the SSDs. Absolute path name. The absolute path name from the root directory all the way to the to the file or the directory or you are in. So the path name we have from the root to a certain file name, just like how I let you see last class when we went into the server. We have slash, which is referred to the root, then the home, then the username, then the other file stored in the over there. The root is the top level directory, referred to using the slash characters, forms a root of a hierarchical tree. This is just like the structure in Windows. You can see that we have the C drive, then Windows, then system, or whatever, or the other portion we have other things. Here we have the same thing. If we are talking about Linux, we have root, then the slash, then the root, then we choose the path for our system, just like this slash, and we decide where we want to go, just like you saw. We have slash home, okay, over here, slash, then home, then the username, and so on. How to change a directory? Changing a directory will need the input from the user using, for example, the shell command. There are a number of programs you can use, but we need to use a terminal or shell when there are a number of programs that you can use. Home directory, unique to each user account. So whenever you have a username, it will take you to your home directory. You need to change directories if you want to go and do another places in somewhere else. Metacharacters that you can see in front of you, this one, can be used to refer to the home directory. BWD, which is print work directory, if you put it, it will give you a directory where you are at right this moment. Give me 1 minute. Let me, if I have the possibility to let you see how it will work. Let me go and see if I can let you see it. There are programs that I want to use, a number of programs that we can use. For me, I use a secure connection. Let me see, where can I find it? for you. And close here. So I use what we call it secure shell for my servers. I have a number of servers. Let me go to this one and put the password in it. Now I can choose to see what directory I'm in, so I can put pwd and it will tell me I'm in the root directory. If I want to change a directory, as I said, cd stands for change directory, which is the command that tells me where I want to go. For example, I want to go to home. Now I'm at the home directory. Okay. Which cd stands for change the current directory in the directory tree. Arguments specify the destination directory. Retrieve path name. The path name file or directory retrieves to the current directory. Print directory. Directory on one step closer to the root of the tree, referred to by two dots. Subdirectory. Directory residing within another directory. To completion, pressing the tab key fills the remaining characters of a unique file name, directory name, or executable program. For example, the bash shell features or LR another features. Viewing file and directories. The print of a directory structure is to organize file into an easy to use format. This section covers various types of files and file names, as well as the different commands used to select file name for viewing. File types. There are different types of files, just like how we work with them. Text files store information in a readable text format containing configuration information. Binary data files store information associated with the executable programs. Executable programs files, and then we have the directory files, which is serve as a placeholder to organize other files. Linked files that have an association with another file. Special device files represent devices on the system, such as a hard disk or a serial port. Named piping files identifying a channel that passes information between processes. Then the socket files, which is allow a process on another computer to write to local file. File name identifier giving to a file up to 255 characters, okay, which is almost 20 characters, as we longer than 25 characters. Can use alphanumeric characters, underscore and dashes and period. File name extensions identifiers follow a dot at the end of the file name, which, just like how we are going to use it if we are using Windows, it gives the type of the file. Most files on Linux do not have a file extension. Okay, now these are the programming language. .c, for example, is the C programming language source code, and .cc or .cpp, which stands for the C++ programming language. And we have a different type of file that you can go through, just like the last one, .sh, which is shell script, which you can run and create a program through the shell. Now the ls, as we said last class, is to list files in a directory. May pass an argument indicating the directory to the list. You can use in options like -f, -l the -f argument option, the argument to view of a list of files and their type. -l option argument to provide a long listing for each file in a certain directory. So if I bring back my shell and I put ls, it will give me the name of each file, which is telling me the users that's available on this screen right this moment. Long listing for each file include 8th component: file type characters, list of permission on the file, also called the mode of the file, hard link count, owner of the file, group owner of the file, file size, most recent modification time, and file name. Okay, so ls-l, and that's what we are talking about. You can see all the information about the file. File command: display file type of any file. Argument: indicate what file or files to analyze. Identifies between different type of executable files. Identifies empty files. Hidden files: files not normally displayed to user. Configuration files often hidden. Files names start with a dot. ls-a command: display hidden files. To view all hidden files and their file type, press ls-af. So let me see if we have any hidden file over there. So list-a, I have one hidden file, so list-af, and these are the files that we are talking about, some of them hidden. And these the options, you have it in the slides that I already uploaded. Wildcard Metacharacters. Wildcard used to simply command specifying more than one file name on the command line. Can match the entire file name or a portion of file names. Can be used with most Linux file system commands. Okay, as I said, the star that I indicate last class is to include everything listed. Now we can join text together. The cat command display the content of a text file to the screen. -n option display line number of each line in the file. Log files containing record of past system events. Most recent event are appended to end of the file. TAC command display content of a text file in reversed order, just like cat. Here we have TAC, which in reverse order, which help with the log file. If you are a system analysis, you don't want to view the content of file because you will have the older content or older information than the new, but you need to start with the new one, so you put TAC and list your order, which give you it in a reverse order. Head command display the first 10 lines of a file. Tail command display the last 10 lines of a file. For head and tail commands, line count include blank lines. Can provide numeric option to specify a number of lines to be displayed. Like you can put head -2 file name and it will display only 2 lines. You can put 20, you can put 10, you can put 5, and it will display. But if you just put head, it will give you only 10. Long text files cannot be viewed using the cat command because the screen will only fit a portion of a file. More command display text files page by page. Pressing spacebar display to the next page. Pressing enter displays the next line, and pressing display a prompt indicating how much file of the file is displayed on the screen as percentage. Less command, same as more command, but can also use cursor to scroll up and down. User can use a keyboard shortcut to indicate with shell while using the less command. Pressing H key gets help screen. Pressing Q key quits the less command. We have more and less command can be used with output of other commands. If output is too large to fit on the terminal screen, use the straight line metacharacters and put more or less command. For example, ls, which is list, -l, which is in detailed, then the line, the straight line or the vertical line, and more. Displaying the content of a binary files. To view content of a binary files, you typically use the program that created the file. Strings command searches for display text characters in a binary file. OD command display content of a file in octal format. Numeric base 8 format. -X option display content of the file in hexadecimal format. Searching for a text within a file. Text tools commands that search for and manipulate text. Regular expressions, text wildcards that ease to search for a specific text. And we can use the grep, which including the grep and the C++, which the languages that we did use in chapter 5 or 7. Now the regular expressions, different from wildcard metacharacterized. Wildcard are interpreted by shell reg xps, interpreted by text tools. Wildcard metacharacters match characters in the file names, and so on. Regular expressions are divided into two different categories. Common regular expression, which is available to most text tools. Extended regular expression, which is less common in and available in only certain text tools. And these are the expressions that you can use. The grep command, which is global regular expression print command, display lines in a text file that match common regular expressions. Grep command display line in a text file that match extended regular expression. Can be written as grep space -e, and then we can use the fgrep, which does not interpret any regular expression. Return result much faster than the grep, can be written as grep space -f. Grep requires two argument text to search for, which can use regular expression, file in which to search. Grep is a case sensitive. For case insensitive search, use -i option, and grep matches patterns of a text, ignoring division into words. Editing text files. Most system configuration is stored in the text files as commonly accessed information such as email or program source code. Most Linux distributions come with several type of text editors. Text editors come into two variation: editor that can be used on a command line, and editor that can use in a graphical user interface GUI. One of the oldest and the most popular text editors for Unix and the operating system, which is the VI editor. Vim Linux equivalent of VI, standard on most Linux distribution. Advanced is a property, not usability. Advantages is property, not usability. Used on Linux and Unix and Linux. The VI editor support regular expressions, can perform over 1000 different functions for the user. The VI editor is called the BI or bi-modal editor. Two possible models. Command mode performs text editing tasks not related to inserting text, such as deleting text, copying text, saving text, changes to a file, and exiting the VI editor. Insert mode, insert text but nothing else. Press the escape key to return to the command mode. User environment is customizable through settings that can be altered at the prompt. Okay, and here you have the option to enter the option for the VI editor. Other text files or text editors: the GNU Emacs editor, which is macros editor, offers a function to the VI to insert Emacs. Run the following command: yom install Emacs. To open a file in the Emacs editor, type Emacs project 4. For example, if we want to open project 4. Emacs editor uses a control key combination to perform special functions. Emacs editor is not easy to use. If you run Emacs within a GUI environment, a graphical version of the editor is started. And this is the editor. We have another editor, which is the Nano editor, text editor that uses the control key combination for performing functions based on the Pin Unix editor. Very basic and easy to use, used by Linux administrator to modify files when advanced functionality is not needed. Control key combination listed at the bottom of the screen. To install, type yom install nano. Gedit editor, a graphical text editor functional in a GUI environment, does not have advanced functionality like VI and Emacs. Easiest editor to use. Functionality is analogs to Windows WordPad and Notepad editors, just like this. This is the summary of the chapter. Chapter 4, which is the second one here, Linux file system management. This is the objective of the outcome of the chapter, and the file system hierarchy standard, which is standard set of directories for Linux and Unix systems, standard file and subdirectories content. Simplifies the task of finding specific files. Give Linux software developers the ability to locate files on any Linux system. Create non-distribution specific software. And these are the file system or the directory defined by the file system hierarchy standard. Managing files and directories. mkdir, a command to create new directories, argument, specify directories, absolute, or retrieve path name. mv command move files, minimum of 2 argument, which is the source file or the directory, and the targeted file that you want to move file to. Path name can be absolute or relative, also used to rename files or directories. cp command, which is copies files command, same argument as the mv command, also used to make copies of files. To copy a directory full of files, you must tell the cp command that the copy will be recursed. To use this command, which copying the directory and all the subdirectories and content, you need to put cp -r option. If the target is a file that exists, both the mv and the cp commands warn the user that the target file will be overwritten and will ask whether to continue. A feature of the default configuration in Fedora Linux, because the bash shell contains alias to the cp and the mv command. To see the alias present in your current shell, type alias at the prompt, which is the terminal. Interactive mode, prompt user before overwriting files. -i option, when you type the cp command, the cp command -i command is actually run. -f option, which is force, which is overwrite interactive mode. rm command remove files. Argument are a list of files. Can use wildcard interactive mode by default. Use the -f option to override. rm directory or dir command remove directories. Argument are a list of files. Can use wildcard interactive mode by default. Use the -f option to override. Cannot be used to remove directories full of files. To delete directory and all its content, subdirectories and file, use rm -r command. And these are the options here. Finding files. Locate command search for files on a system. Receive full or portion file name as an argument. Looks in a pre-made index database of all files on a system. To update the database, use the update db, which is database command. Information returned may not fit on screen. Find command, which is search for files starting from a specific directory. Slower than locate command, but more versatile format, and this is how you want to find something. If you're using wildcard metacharacter, ensure that they are interpreted by the find command. To reduce search time, specify subdirectory to be searched, and these are the find command. Finding files. Path variable, which is list directories on a system where executable files are located, allows executable files to be run without specifying absolute or relative path. Which command? Search for executable file. Search for the path variables. If the file is not found, list the directories that were searched. Files can be linked to one another in two ways. Symbolic link, one file as a pointer or shortcut to another. Hard link, which is two files share the same data. To better understand how files are linked, you must understand how files are stored on file system. A file system has three main sections. Superblock, containing general information about the file system, which is number of innodes and data blocks, size of each data block. The innode table consists of several innodes, each of which describe a file or a directory and contains a unique inode number for identification. Data blocks, which is data making up content of a file. Hard link files share the same inode and inode number, must reside on the same file system. To create a hard link, use the ln command and specify 2 arguments. To remove a hard link file, delete one of the link files, which is reduce the link content of the file. And this is how the structure of a hard link. Symbolic linked files do not share the same inode and data block with their target file. Symbolic link file is a pointer to the target file data block in the linked file containing only a path to the targeted file. Editing a symbolic link file actually edit the target file. If the target file is deleted, the symbolic link serves no function. To create a symbolic link, use the -s option with the ln command. 2 argument existing file to the link and target file to create as the link to existing file. Argument can be retrieved and absolute path names. Use ls-l command to view both hard link and symbolic link files. Symbolic link need not reside on the same file system as their target. File directory permission. All users must log in with a username and password. Username identified by username and group membership. Access to resources depend on a username. Group membership must have a required permission. Primary group, user's default group. During the file creation, the user name and primary group because the owner of the group and group owner of the file. Same for directory creation. Who am I? Command view current username. Okay, let's try it. Which give you command. Other one, which is group, which is give you the group. Here touch create an empty file. Chown, which is change owner, changing ownership of a file or a directory. 2 argument, new owner and file or directory to change. Can use the -r option to change permission throughout the directory tree. Change group command, changing group owner of a file or a directory. Mode in node section that stores permission. There are 3 sections based on the user that receives the permission. User permission, group permission, other permission. 3 regular permission may be assigned to each user: read, write, and execute. And here is the permission. Here's the user: read, write, and execute. Then the group: read, write, and execute, and other, which is read, write, and execute. And you can have the user have it and all of them dashes. User refers to the owner of the file or directory. Owner refers to the user with the ability to change permission on the file or directory. Other refers to all users on a system. Permission are not additive. The system assigns the first set of permission that are matched in the mode order. Linux permission should not be assigned to other only. Changing permission, which is the ch mode, changing mode. Change mode, which is the permission of a file or a directory, takes 2 arguments at a minimum. The criteria used to change permission in a file to change permission. If the permission to be changed are identical for the user group or other categories, you can use the A character to refer to all. Permissions are stored in an A files or directories in Node as a binary power of 2. And this is, as you can see, the permissions. Default permission. New files are giving RW permission by default. You mask a special variable that takes away permission on a new files and directories. Umask command display the umask. Changing the umask. Use a new umask as an argument to the umask command, and this is how to be done. Let's see. Special permission. 3 more optional special permission for files and directories. SUID and ID, which is set user ID, set group ID, and sticky bit. Defining special permission. SUID, which is set user ID. If set a file name user who execute the file becomes owner of the file during the execution. The pass WD command. No functionality when set on a directory, only applicable to binary compiled programs, cannot be used on a shell script. SGID applicable to files and directories. If set on a file, user who execute the file become member of the group during the execution. If a user create a file in a directory with the SGID set, the file group owner is the set to be the directory's group owner and not the user primary group. Sticky bit, which is previously used to lock files in memory. Setting special permission. Special permission require execute. They mask the execute permission when displayed by the list-i-l command. May be set even if a file or directory does not have an executable permission, indicating later in the mode with the capitalized add special permission via ch mode, which is change mode command, and you can see the special characters. Setting special custom permission in the access control list ACL. ACL a list of a user or group that you can assign permission to. Set FACL, which is set file ACL command used to modify ACL entries for practical Linux file or directory. Use the -m option to modify the ACL, and use the B option to remove all extra ACL assignments. Get file ACL command used to list all ACL entries for practical Linux file or directory. Managing file system attributes. Linux has file attributes that can be set, which is list attributes LSATTR, which is list attributes command used to list file system attributes for Linux file. CA, which stands for change attributes command used to change file system attributes for Linux files. And we have the I, prevent files from being modified in any way. And this is the summary of the chapter. Hopefully this lecture, the quick lecture, helped you with just will work as a replacement for the lecture. I advise everyone to do the labs, which